Okay, let's graph this. This is a piecewise function um, where we have basically two equations. We're going to graph y equals 2x, and we're going to graph y equals 2x plus 1 with these different parameters. Well, let's draw the graph. X here, y here. Well, let's first graph y equals 2x. Well, that particular equation, y equals 2x. Well, the y-intercept, remember y equals mx plus b. Okay, your y-intercept is 0. Your slope is 2. So I'm going to start here. I'm going to use my slope to get to the next point. Go up 1, 2, over 1 here. But watch this. I'm only going to put the points because I don't want to draw my line yet. Because look at my parameters. It says if x is less than negative 1. So I don't want to graph this until x is less than negative 1. So watch what I'm going to do. I'm going to go to negative 1. But I'm going to use my slope to get to that point. Watch what I'm going to do. Actually, I want to use this negative 1 to give you my endpoint. So I'm going to plug negative 1 in for 2 to give you that y value. So if I plug in negative 1 in for, it's not negative 1 in for 2, negative 1 in for x. Negative 1 in here. So I'm going to have negative 1 times 2, which is negative 2. So the first ordered pair for this particular one would be the ordered pair negative 1, negative 2. So if I plot negative 1, negative 2, it's going to be here, which you notice falls on that line. But I'm only going to graph from here. And since it says x is less than negative 1, I'm not going to include that. And notice my line is going in this direction. I'm just going to draw that part of the line. This, I don't even need it in this function. Okay? Now I'm going to graph 2x plus 1 if x is greater than or equal to negative 1. What I would probably do first here, plug in negative 1 for your endpoint and then go from there. Let's see. Negative 1 and then negative 1 in here for 2. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. That's my corner point. So I'm going to go to negative 1, negative 1. I'm going to start here. That's where it's going to start, which notice it's actually going to, we're actually going to place it right here. And it's going to be a solid dot. And now I need to see how to draw the rest of my line. There's a few ways you can do this. What I would probably do, since you already have a starting point, use your slope to get to the next point. Since your slope is 2, I'm going to rise up 2 units. 1, 2, over 1. Put another dot here. I'm going to draw that particular line, starting here. And here's your not going through that line. That's a mistake. So your line's going in this direction, straight this way. Kind of got a little mess here. Ignore this part of the line. And this is the other part of the line here. Okay, for this last problem, this is an absolute value function. For this one, you want to remember what your absolute value function looks like, your parent graph. And once you know the parent graph, you're going to use this shift to actually sketch the graph. It doesn't have to be exact. We just want to sketch. And you got to kind of remember your graph theory to do this. Okay? To remember graph theory, here, this plus 6 is going to shift the graph 6 units to the left. This minus 2 will be a vertical shift, and it's going to move the equation 2 units down. This is going to squeeze the equation, make it skinnier, by a factor of 3. So the graph of y equals absolute value of x is going to look something like this. I'm going to plot my points. It's going to be a V. Okay, that should be a V. It's a sad V. Alright. Well, I'm going to do some shifting. You're going to go 6 units to the, which way is it left? 1. Let me put some more lines here. 1, 2, 3, 4, 5, 6. 2 units down here. It's going to be upside down. And, excuse me, it's going to be the right side up. But it's going to be a little skinnier.